Okay, so question 5, survey on households undertaken to provide information on the number of children per household. So there were 99 households with children, 99 households. That's important. So for all these 99 households, calculate the values for the median. So the median is the middle one. So you have to remember that's the n plus 1 over 2 one. So 99 plus 1 is 100 divided by 2 is the 50th one. And be very careful, it's not 50, it's the 50th one. So 14, 35, if you keep a cumulative total, the 50th one would actually be somewhere in that 25. So you can say that the median is 3. The median is 3. Now the interquartile range, so you need the upper quartile and the lower quartiles, and again the lower quartile is the n plus 1 over 4th one, and the upper quartile is the 3n plus 1 over 4th one. So with that being n being 99, that's 100 over 4 is the 25th one, and the upper quartile is 3 times that's the 75th one. So again, keep your running total. So the 25th one will be in the will be one of the 35 of houses who had 2. So the lower quartile would be equal to 2. Now the upper quartile being 75, so keep your running total 14, 35, 25. So the 75th one will be one of the 13 households with 4 children. So the upper quartile is going to be equal to 4. And the interquartile range is the difference between those. So 4 take away 2. So interquartile range is equal to 4 take away 2, which is 2. I've so many times I've seen students do 75 take away 25. Remember this is just the position. It's not the median or the upper and lower quartiles. They're just the position of them if you were to order the 99 households. For the mean and standard deviation, I'll do this on my calculator. So type the table into your calculator. Calculate x bar. If I do that, it comes out to be 2.78 for the mean, and the standard deviation. All of the households on an estate, all of the households. So I wouldn't do the n minus 1 standard deviation. I would do this one. So that would be 1.307. Okay, standard deviation is 1.307. So all that's done on your calculator. Now, for part B, in fact, 163 households were surveyed, of which 64 contained no children. So you could, if you want to, imagine that there was another sort of column in your table. State whether or not the value for the standard deviation would be smaller than, the same as, or greater than. So I want you to pick one of these, smaller than, the same as, or greater than. Now remember, standard deviation is a measure of spread. So by adding 64 people with zeros on there, the standard deviation, I would imagine, would be increased. So would be greater than that, calculated in part AII. It's not the same as if you add 10 to every single value, in which case you'd expect the standard deviation to stay the same because all the values have changed by the same amount. You've actually introduced 64 zeros, so I would imagine the standard deviation would become greater. Okay, so it's claimed that for the 163 households, the number of children per household may be modelled approximately by a normal distribution. Comment with justification. Well, I don't think you could use the normal distribution here because if you look at the numbers, it wouldn't be symmetrical, would it? It wouldn't sort of be a symmetrical distribution. It's very highly skewed because so many house